Hello friends, welcome. Friends, I'm sure whoever is watching this video might have seen this news. This news has been a point of discussion in social media for last 3 days. So if you see that, it says Telegram CEO is arrested at French airport. Now, what is the reason for his arrest? We are not sure because nothing has been spelled out by the law enforcement agencies. But there are speculation all over the place saying that he refused to grant access to law enforcement authorities on messages which is flowing into his system, which is Telegram system, which could have been used by anti-social elements to promote certain activities which are illegal where French authorities were concerned. So that is the reason why probably he has been arrested, but it is not very clear the reason why he has been arrested. So friends, what I thought is, I took this opportunity to dive a little deeper into this whole issue about legal interception of messages, because everybody knows that there is a tussle between the government and the various service providers regarding legal interception. The government wants the messages to be intercepted for ensuring law and order, and the civil societies wants that nobody can tap into their communication, because anything that is not secure is open to misuse. Various kinds of people can misuse, and government can actually go a little bit further, overreach, to even there is a tendency to curb opposition voice by listening to communication, which is not the purpose of legal interception. So friends, what I thought, I created some slides, some questions I posed, and these are the questions. And what we will do is we will make an attempt to answer these questions and try to analyze whether legal interception is a viable method of monitoring all kinds of activities which is happening on the internet. Are there any methods which are available which can easily circumvent legal interception, which the law agencies are trying to enforce on the application providers? So that's the main point of this discussion. And what I'm going to do is, in this video, I'm going to basically go very high level. I'm not going to use any technical jargons, and will make this conversation very simple for anybody to understand who doesn't have a technical understanding. I'm going to use certain view graphs to explain to the viewers that how communication system works in a typical setting. We'll take various kind of legacy system, OTT system, and new technology system, and try to explain that what are the opportunities and constraints regarding legal interception. And this is going to be without using any technical jargon. So whoever is watching this video will find this discussion very useful, because I'm not going to use any technical jargon, simple line diagram, which can be very easily understood. So let's basically talk about which are the questions that we are going to address into this discussion. So the first question is, how do legal intercept work across various technologies? Very, I think this is the most relevant question anybody can ask, because you need to first understand how it works. Unless you understand how it works, how will you know that how easy or difficult it is to circumvent it? Then the next question is whether legal interception is always feasible. The third is that when is interception not just difficult but impossible? Means, what are the situations where you can't even penetrate into the calls which are flowing through the internet or any system? Are internet-based system based calls truly secure and encrypted? That is the next question we are going to answer. What about metadata? Metadata is basically signaling, which is because there are two types of information which flows in any system. One is the bearer traffic, where you actually are talking between each other. Another is signaling, which is setting up the call. So that's called metadata. Now, whether metadata is left unprotected and why it is left unprotected, we will answer that question also. Can backdoor be built to bypass encryption? That we will answer. and how and where these backdoors are implemented. Okay, so these are the things we are going to answer, and let's go straight to the presentation one by one. We have already 5 minutes into this video, so let me just take my face out. It will become easy for me to explain. So let's go to the first slide. Now if you look at the first slide, let me just blow it into the screen so that it becomes easy for me to take you through the slide. Now we are going to first talk about circuit switch network. Right? Before talking about packet switch network, let's talk about circuit switch network. Don't get overwhelmed by this chart. It's very simple to understand. Circuit switch is what? Simple mobile network. You have seen towers, so these are the towers. These are the mobiles which are locked to the towers. Okay? The simple mobiles which are locked to the towers. So there are various towers which exist into the network, and they are all connected to mobiles. Whichever mobiles find a tower, it gets hooked into that particular tower. And then there is a switch in between. Okay, so this is how it is, diagram is built. Now, the calling party, which is a mobile A, trying to reach the called party. This is the called party. So how that call flow happens? The call flow happens between the network, that is the tower, through the switch. So the call flow will go like this. It will go to the tower, through the switch, and then through the switch it will go to the tower in which mobile B is connected, and then finally the mobile B will be connected to in mobile A, and they will talk to each other like this, right? Now here is the issue. The issue is that this switch, the switch in between, actually has to first find where mobile B is. So all these devices, whether mobile A, mobile B, C, D, etc., they have to all register into the switching system. Means they have to advertise their position within the switching system. That look, I am here, I am here. So there has to be continuous advertisement happening by all the devices into the switching system. That switching system should know where these mobiles are. Once they know, then when one mobile wants to dial another mobile, then as soon as it makes the request through the signaling system, that the signaling unit of the switch will immediately able to tell that look, mobile B is in base station so and so, I will make that call connected, and once that call is connected, I will allow a bearer channel, and through that bearer channel we can talk. Now I am not getting into the technical details, as I told you that I am going to make it very, very simple. There are two things to note here. Both the signaling link as well as the bearer path passes through the switch. They are not independent. They are all passing through the switch. So the service provider who is managing the switch has control over the signaling channel as well as the bearer path. And in case of a circuit switch mobile network, both these paths are clear text. Means they are not encrypted. They are simply let through the switch in clear text form, which basically means that the operator can record the conversation, including the metadata, into a storage device right here. And that storage device can be called for by the law agencies, and that's the way legal interception happens. So there are two types of legal interception. One is through storage and one is live when the call is progressing. Both kind of legal interception happens. So summarizing this particular part is that the signaling as well as the traffic flows in clear text form through the switch, and therefore it can be very easily stored in the storage device. Now let's go to the next part of the discussion, which is a packet switch network. Let's talk about packet switch. So I am in a different chart here. Here where what I am going to do is I am going to talk here about how a packet switch call takes place through the internet. So let me take my face out so that the full picture is visible. So here you will see that I have what? I have a cloud. Cloud is what? Open internet. So this is the open internet. Now in this open internet, what are the things which are connected? So I have got an ISP provider which is connected here. I have a mobile operator which is connected to the mobile open internet. And I have the OTT service provider which is also connected to the open internet. Sorry. All the three players are connected to the open internet, right? Using various kinds of systems which are available, optical fiber, anything that is possible. So these are the connected links. Now what is the purpose of an ISP provider? The ISP provider is providing services to these computers, right? You see these computers located here, they are providing internet services to these computers. So there are two ISP providers. So I marked ISP provider as one. Here is also an ISP provider. And the mobile operator, they also offer two different type of services. One is circuit switch, we have already explained. Another is internet access, which you might have already seen. You might have already accessing internet. So mobile operator is also offering two different services. Therefore, it has to connect to the open internet. Now, you have got WhatsApp here. Let's assume that the WhatsApp is sitting right here, which is also connected to the internet. So now let's try to play how a typical WhatsApp call takes place. So let's say if you are a mobile user here, and if you want to talk to another user here, let's say here, another mobile. So what you will do, you will basically call through the mobile operator, through the open internet, you will go straight to this server of the WhatsApp service provider, right? Who is basically managing the server. This server will know the IP address of the other user which is located here, because ultimately only way to reach a device which is connected to the internet is through the IP address. So unless the IP addresses are available, you will not be able to connect. So there has to be a system in place here which will be able to understand where this device is and what is its IP address. Similarly, where the other mobile is, what is its IP address, right? And then once the IP addresses are determined here in the OTT server here, the server which actually has the signaling link inside that server, signaling processing cable inside the server. So what it will do, it will basically tell this device, let's talk about this device because I was basically talking about this device. So it will tell this device that, look, this device has got the following IP address, and it will also inform this device that this guy is trying to reach you and it has the following IP address. Once you know the IP addresses, then the link will be established via the OTT server through the mobile, not directly through the internet, because the OTT server acts as a medium for both the signaling as well as the bearer path. So point to be noted here that the information that flows between the mobiles which are trying to talk to each other doesn't happen through the operator's network, mobile operator's network, but through the OTT server's network, which actually is able to drive both the bearer channel as well as the signaling channel in a certain situation. There are situations where the bearer path is going to be completely separate. We are going to talk about that. Now, since the OTT server, let's say WhatsApp, has the information of metadata which is signaling as well as the bearer channel which is flowing through it, if it is able to break into this encryption, then what it can do, it can store the information about the bearer path, whatever is flowing, whoever is messaging whom, as well as the metadata, which can be called for by the legal for interception by the law agencies. So this is how it works. But the point here is to be noted is most of the time the bearer channel is encrypted end-to-end by the client software which is sitting here. So you have a WhatsApp app. That WhatsApp app will do an end-to-end encryption, though it is passing through the server, but it will be end-to-end encrypted. So this OTT server may not have the capability to break in, right? But that's not the complete story. Now the OTT application provider also controls the client, which is sitting here in the mobile phones. Now these clients are talking to each other through an encryption protocol. Now since the client is controlled by the WhatsApp service provider or any service provider, therefore whatever keys are getting exchanged between these two points through the OTT server can be called for. That's how a backdoor can be created by the WhatsApp server, and it can break into the conversation because the client is controlled by the WhatsApp service provider. The client is not an independent entity. It is a software which has been provided by WhatsApp or Telegram themselves. Okay, so that's why both the signaling path as well as the bearer path can be unlocked. Signaling is anyway free most of the time. It is clear text because it has to read the signaling, otherwise how it is going to route the call from here to here. So signaling is always has to be broken in. It is not secure. At least the service provider is able to see through. But the bearer path can be fully encrypted, and there is an option that the OTT provider can provide a backdoor for the legal interception for the law agency. So that is the second part of the discussion. Now let's look at that so we have already discussed this. Let's look at another protocol called WebRTC. This is important. This we have to understand. There is a new protocol called web real-time communication. Now this communication is a phenomena which has become very prevalent after COVID. So what we do typically here, you can actually do peer-to-peer communication, peer-to-peer, and it does not require a server. So you don't require a server. Only server that is required is the signaling server. Because let's say this mobile which is connected to the internet, here is also connected to the internet, and you have to talk from this mobile to this mobile. Then for the signaling path, you have to travel through the server. But the bearer path is independent of the signaling server. It travels directly peer-to-peer. Now, how does it work? So let's understand how does it work. Now, in order to understand how does it work, we have to understand certain principles. The principles are as follows. Now, anybody who wanting to talk to anybody in a communication system, let's say I am there here. Sorry, just a minute. Let me go back. I think I have lost that chart. Just a minute. Yeah. So let's say this is me here and this is you, right? Now, there may be many mobiles, right, or many devices which will be connected to the internet. How do I know, as an individual user, how do I know what is your address? I will not know, because in internet, everybody has got an IP address. But there is no way for me to know who to talk to. If I know your IP address, right, unique IP address, then there is no need for any signaling server or anything. I can simply connect to you directly through the IP address, because IP address is a telephone number which you dial. You can connect to any devices within the internet. So it's a question of knowing the IP address. So every device which is connected to the internet has an IP address, and some of the IP addresses are protected, on a private site of the network, which is called local network, where you do not have public IP, you have got private IP. Let's say if you are connected to a Wi-Fi network in your house, the IP address that you see on your mobile phone, it is not a public IP address, it is a private IP address. So therefore, for me to find out your IP address, it is virtually impossible. I cannot do so, right? So I need a system which can unlock the IP address, and that is why any system which is wanting to discover itself by another user in the internet has to register into a server or a registering entry. So you have to disclose your identity, and you have to register into a database in a server, which is typically a signaling server. Because unless you register yourself and disclose your identity and where you are, there is no way you can be discovered. So you have a list here, right, in the signaling server. In that list, all the party which is subscribing to that service will be registered. Now let's say I want to reach you. So what I will do, I will go to the signaling server and I will request that, look, this is the guy who I want to talk to. Please give me his IP address. I'm actually making this very simple. This is too complicated, by the way, but I just want to make it simple for everybody to understand. So I will request the signaling servers to please find out this guy what is his IP address. So what the signaling server will do, it will be able to look into this database, and since this guy is registered there and continuously communicating with the signaling server, it will know his IP address, right? Or there is some other mechanism which is technical in nature, but I am not talking about that will make the discussion too complicated. So let's assume that the signaling server is able to figure out the IP address. Once the IP address has been figured out by both the parties, this guy should know his IP address, right? And I should know his IP address. So once the IP address has been figured out and communicated back, right, by the signaling server to both these entities, then there is no need for the signaling server. The signaling server is out of question, then I can basically communicate directly to this device. That is the whole purpose of WebRTC. So it's a peer-to-peer communication. Here, the bearer path does not travel through the signaling server. So whoever is maintaining the signaling server, he doesn't have access to the bearer path. So once he doesn't have access to the bearer path, how he is going to provide a legal interception? Let me ask you, how the legal guy law agency will be able to tap onto this conversation which is flowing in the internet through an encrypted protocol end-to-end state. There is no way. But there is a catch here. The catch is very simple, that again there will be some service provider who will be providing an app which will be hosted in the mobile phone. The mobile phone cannot make calls just like that. There will be an app. Here also there will be an app. This app will be controlled by this operating provider who is providing this service. So what this provider can do is they will be able to route the call instead of going through the internet but through this server. They can do so because they have control over the app through which you are calling, and they will also have access to keys. So though this a WebRTC protocol is an end-to-end protocol peer-to-peer, but if there is a demand and if there is a will, then this bearer channel also can pass through the server, and then it can be stored by decrypting and recorded and provided to the legal lawful agency for legal interception. You got it? That is the reality. There is nothing in the system which is completely tamper proof, but there is one way. Let me explain what I basically mean. Now let's say the signaling server is not maintained by an operating agency or a provider. It is maintained by some group of antisocial elements who do not have any control, and their intent is to communicate with each other and do all kind of antisocial activities, right? It's very easily possible. So what they will do is, normally they won't be able to communicate with each other because, as I told you, discovery of the device in the internet is not possible, because both of them who are communicating through the internet has to know their IP address. Without IP address, they will not be able to communicate. So what they will do is, they will set up a signaling server and write a program which is very easy to do. Earlier these kind of programs were written in C++. Now it is being so easy to write. You can basically have all those AI applications which can write this in a matter of 10 minutes. So you set up a signaling server, and those people who want to talk to each other, they can be part of this group which is not maintained by any commercial service provider. Okay. And you may not even use a browser which is let's say managed by Apple or anybody else or Google, etc. You can use your own, you can write your own HTML code and create your own browser here. And you can use open source browser. There are a lot of open source browser available. Now, having set up a system like that where the signaling server is your own, it is not controlled by any commercial entity, then what you can do? You can basically get yourself registered here. All those antisocial elements will get registered here, and wherever they are moving, they will be able to talk to this entity and they will register here. And this signaling server can be located in an Amazon cloud, or you can move it in a random way anywhere in the world. You can talk to the signaling server even using a VPN. Now since this location of the signaling server is not static and moving, once the call has been set up by the signaling server, then the bearer path is independent of the signaling server, and it can be and the communication between the two entities, once the IP address is known, can be through a strong encrypted protocol. Then there is no way you can break in. And this is very easy to implement. There is no complication to that. Now tell me how it can be legally how legal interception is possible in a situation like that. So that is the point which I basically want to say, is that not in every situation legal interception is possible. And in today's world, the world has moved to such an extent that these kind of applications are easily possible to be developed, maintained by private entity who has only an interest to talk to each other and spread all their anti-social activities, without having to use a commercial system. So therefore, since these are easy to do, therefore whatever amount of legal interception that you actually set up to tap into and try to catch hold of criminals, terrorists, etc., you will end up catching only petty thieves, and those are going to be misused by rogue government with an intent to curb the voice of the people and opposition. right? So that's the problem with having legal interception. If the legal interception is not properly managed and there are constitutional provisions there which makes it very difficult, and we have seen that legal interception has been mismanaged like hell. Every government, there have been multiple cases where calls have been recorded and been put in public domain, and all those conversations are all available, and that I don't have to say anything about it. So the legal interception has been misused. It has happened in US, it has happened in many other countries. So, but today, with this kind of system in place, which is easy to implement, what is the purpose? Any terrorist organization can set up all this system and discover themselves within the internet without having to have a huge amount of paraphernalia of knowing their IP address, which can be very easily discovered. So friends, given this situation, I thought that let me just do this video, because I wrote an article also on this subject. I'm going to paste a link of this article in the description, which kind of talks about exactly what I spoke. I got a little bit of detail, but it is almost exactly what I spoke in this video. And if anybody is interested, they can go through this article on top of listening to this video. So hope that you probably understood what kind of problems that we are facing in this world, challenges and opportunities. So the law agencies, so let me just end this video by saying that we can actually have a middle ground. The middle ground is that, as I told you, that there is metadata and there is bearer channel. So the bearer channel is a conversation happening between two parties, and that is completely secure. So let's not tamper with that. But the metadata, which is the signaling channel, which is anyway available to the service provider, because he has to get into the signaling system and try to understand it, and therefore he can set up the call. That information should be provided to the security agencies or the law agencies whenever they need, and that will provide a lot of insight other than breaking into the conversation. So that's maybe a middle ground which can resolve many of the issues that we are facing in the model world, which we need to overcome. So thank you friends for your time, and I hope that you like this video, and I'll come back to you next time with a new video. Thanks a lot.